In order to evaluate these integrals involving powers of sine and cosine, I need some guidelines. So when the power for the sine is odd, and remember, it always has to be positive, what we're going to do is we're going to save one sine factor and convert the remainder to cosines. And we'll expand and integrate. So what I show you is if I have sine to the 2k plus 1 of x cosine n of x dx, notice this is odd. Okay, so I'm going to rewrite it as the integral of sine squared x to the k power. So I took care of the 2k, and now I'm going to have times sine x and then cosine the nth power x dx. I'm going to rewrite this as 1 minus cosine squared x. So now I have the integral of 1 minus cosine squared x times cosine the nth power of x times sine x dx. And we can integrate that. What we're going to do is we're going to use this for our du, and then we'll multiply these out, to the k power here. And we're going to multiply these out, and so that you have two things in cosines, and you can integrate it. The next one is when the power of cosine is odd. So the power of cosine is odd, and remember it has to be positive because we said that was one of the things we had. We're going to save one, same thing, we're going to save one cosine factor and convert the rest to sines. So we'll have, let's say for an example, we'll have the integral of sine to the mth power x, okay, cosine to the 2k plus 1 power x dx. So this number here is odd. So I'm going to rewrite it as the integral of sine to the mth power of x times cosine squared x to the k power times cosine x dx. So 2k plus 1. I'm going to rewrite cosine as 1 minus sine squared x, and I'm going to have the integral of sine to the mth power of x, 1 minus sine squared x to the kth power, cosine x dx. And I'm going to use this for my du. I'm going to expand this, and then I can solve it. We have one more. The last one is when the power of sine and cosine are even, and of course positive. Well, actually they could be 0, even and positive, or just non-negative. Okay, so I'm going to use those identities I was talking about. So I'm going to use these two identities. And I may have to use this many times to convert it into odd powers of, what I want is odd powers of cosine. And then I can go back to number 2 that we did up here and solve it that way. So we may have to do it more than once. It doesn't matter, sine or cosine could be something in sine or cosine that's positive without the other one. We'll just integrate it that way, and we'll look at some examples to see how this works.